So if we want to get the area of a triangle, the best way, as I said in the last video, is just to think of this shape we have here for a triangle as being half of a parallelogram. We could almost get, if we took that thing and just flipped it over the top like so, we would see that we have half of a parallelogram. So the idea of trying to find the base as for a parallelogram is just a bottom side length, and then a height is again something like that sort of altitude dropping from a top corner down to the bottom, not along a slant because that would be a little bit too short. But in any case, we would end up with hopefully a familiar formula here that to find the area of a triangle, we have 1/2 base times height. Again, pretty straightforward. It's just half a parallelogram, half a rectangle. It's not so bad. So let's take another example here to see how we would do a computation for a triangle. For this, we want to find the area of the given triangle below, where what we should be careful of here is that when we're dealing with the area of a triangle, we don't just want the base in terms of any side length. We want the base in terms of the longest side length and the altitude in terms of the height from that longest side up to the top vertex remaining. So in this case, our longest side is the one on the bottom there, so it fits nicely to be the base, is 16 meters, while the altitude in terms of that is given by the dotted line is 10 meters, which means our area here will be 1/2 times 16 meters times 10 meters, where 16 times 10 is 160, divide by 2, and you have that the area here is 80 square meters. Not super complex, we're still doing pretty basic stuff. So now that we have a pretty developed idea of how to get the areas of triangles and parallelograms, we can essentially staple these together to talk about how we want to get the area of a more general quadrilateral of something like a trapezoid. I blanked on the word there, but well, we'll see it in a second.